Welcome to the Deep Dive. We dig into sources to pull out, well, the key insights for you.
That's the plan.
And today, we're diving into someone you definitely think you know, Leonardo da Vinci.
Right. Everyone knows the name, the painter, the inventor.
Exactly. But we're going beyond, the Mona Lisa guy or the inventor or even the anatomist. We want to look at him as something, well, maybe deeper.
Something like the Renaissance's first real motion observer.
Yeah. And maybe even kind of a foundational motion theorist. Way, way ahead of his time.
That's really our mission here. We're exploring how Leonardo, centuries before modern physics, before calculus was even a thing.
Right, long before.
How he just intuitively got these fundamental ideas about motion.
And not with equations, right?
No math as we know it. It was sheer observation, this incredible intuition, and honestly, just taking the time, really watching.
Okay, so get ready for some potentially big aha moments listening to this. We're going to try and show how his work basically presaged what modern motion theory would spell out later. Now, you might be wondering, okay, what is motion theory? Maybe we should clarify that quickly.
Yeah, good idea. Think of it as a way to understand how basically everything, water, bodies, even ideas, it's all constantly moving, changing, interacting.
Okay, in flux.
Always in flux, yeah. And always trying to find some kind of balance or resolution. It's about seeing the patterns, the rhythms underneath what looks like chaos.
Got it. So connecting that back to Leonardo.
Well, he wasn't just looking at static things. He was looking past the surface, wasn't he? He was seeing the dynamic processes, the movement itself.
Okay, let's unpack this then. How did he do it? How did Leonardo manage to see these loops and patterns and rhythm when, well, presumably others just saw stuff?
Yeah, or just chaos, maybe.
Pretty amazing when you think about it. No textbooks, no complex math.
He didn't need them. He had his eyes, that amazing intuition, and just patience, time.
So when we say he had eyes of a loop, what does that really mean?
It means he saw cycles, recurring patterns where other people just saw separate objects.
He'd draw the movement, the underlying pattern, not just the shape of the thing moving. And he was listening, in a way, for the rhythm in things, not just measuring their dimensions. It's almost like he was watching motion think. Does that make sense?
That's a great way to put it, actually. Watching motion reveal its own logic. He really did see reality through a different lens.
And nowhere more clearly than with water, right?
Well, absolutely. Water was his obsession.
You just look at the notebooks. They're packed, just overflowing with sketches. Whirlpools, eddies, rivers flowing.
Wave crests, hydraulic machines. I mean, it's endless.
Yeah.
Clearly, no kind of motion grabbed him quite like water.
And he seemed to understand it so deeply.
Yeah.
That it never repeats exactly, but it always follows some kind of
motion logic, yeah. He got that.
He wrote that famous line, didn't he? Water is the driving force of all nature.
He did. And you get the sense he didn't just mean that poetically. For him, it was like a structural truth, how the world works.
And this is where it gets fascinating, connecting it to motion theory.
Exactly. Because motion theory sees water in a similar way as structured movement that's always resolving, always adapting through, flexible constraints, seeking equilibrium.
So he was basically intuiting fluid dynamics concepts hundreds of years early, just by looking.
Pretty much. Can you give some examples?
Yeah, absolutely. Take his drawings of vortices, whirlpools.
Okay.
He clearly saw each one as a self-sustaining loop. It's this continuous pattern feeding back into itself, holding its shape even as the water moves through it. I can picture that.
Or river bends. He saw them as gradient sync resolution.
Gradient sync resolution.
Yeah.
Okay, break that down.
It basically means he understood how the water's flow adjusts, how it finds a kind of harmony with the shape of the land. It creates those stable, smooth curves it's syncing up.
Adapting to the environment.
Precisely. And wave crests, he saw those as phase convergence under environmental tension.
Whoa.
Yeah. Essentially, he observed how different forces in the water kind of line up, converge at one point to make that peak.
Only for it to collapse again.
And reform.
Right. That's really something. He's sketching out principles that science wouldn't formalize for ages.
He really was. He saw that water is recursive. You see similar patterns at different scales.
Like small eddies and big whirlpools.
Exactly. And that it's adaptive, obviously, and that it has this rhythmic intelligence. His drawings just capture that dynamic quality.
Amazing. And from water, he looked up to the air. Flight.
Another obsession. Birds, especially.
He was dissecting wings, right? Trying to mimic feathers, designing flying machines.
Yeah, but it wasn't just fantasy. He genuinely believed that the rhythms of air could be figured out, decoded, mastered even.
What did he observe there?
Well, he noted that lift emerges from looped pressure differentials. You can almost picture it, right? Air flowing over and under the wing.
Creating different paths, different pressures.
Invisible loops, yeah.
Yeah.
And that difference pushes the wing up. He also saw that wing motion isn't brute force, it's phase coordination with ambient motion.
Okay, so not just flapping hard.
No, it's about timing. It's about the wing moving in sync, coordinating perfectly with the air currents around it.
So if motion theory looks at flight, it's not just power versus gravity.
No, it sees it as much more elegant, more like structured motion synchronizing with fluid gradients.
Okay.
The goal is to reduce resistance, yes, but also to increase this kind of rhythmic lift. It's a dance.
So even though his flying machines didn't, fly.
No, they definitely didn't. But his observations about airflow, turbulence, oscillation, those were like early blueprints for understanding motion in air, hidden in plain sight in his notes.
And he took these ideas beyond just nature, right, to machines.
Yes. He applied the exact same principles to human-made things. He wasn't just drawing static parts like gears and pulleys and isolation.
Like designing systems.
Systems, exactly, with what we'd now call feedback logic.
Like what? Can you give an example?
Sure. He sketched out things like weighted arms that adjusted position dynamically, meaning they could sense a change and sort of correct themselves.
Okay, self-adjust.
Or pressure-regulated valves for water systems, designed to open or close based on the flow, self-regulating. And camshafts with recursive timing, where the movement of one part triggers the next in a repeating timed cycle.
So for Leonardo, a machine wasn't just a pile of parts.
Not at all. It was a loop with constraints. It was a system where motion fed back into itself, always trying to achieve something, almost like a motion translator.
Interesting. Seeing them as active systems, seeking a rhythm.
That's it, exactly. From the motion theory viewpoint, a machine is like a nested loop of structured motion-seeking rhythm through external constraint.
Wow.
His devices were basically analog sync systems, built hundreds of years before electronics. He was using wood and metal to make things that responded to phase and force.
That's incredible. And then he applied this same vision to the human body.
Yes. The ultimate machine, in a way. And here's where it gets really interesting.
His anatomy work. Legendary stuff. Dissecting, over 30 bodies?
At least. But again, he wasn't just listing parts, he was mapping motion.
Yeah.
Well, he drew how the heart didn't just squeeze, it actually twisted.
Twisted.
Yeah, a kind of rotational movement with each beat, which we now know makes it much more efficient.
Boy.
He understood how muscles pull together in sequence, in rhythm, not just one muscle working alone. That's what creates smooth movement.
Right, coordination.
And he sketched blood flow showing layered motion gradients. He saw that different layers of blood inside a vessel move at different speeds.
He wasn't seeing a static structure. He saw
motion in symmetry. An interconnected dynamic system, always adjusting, always balancing.
And that heart observation. That's pretty profound.
It really is. He was the first one to say the heart is a hydraulic spiral.
A spiral.
He saw it contracting and twisting like a vortex, the spiraling, self-organizing flow. That's not just anatomy class, that's pure motion theory.
How does motion theory see biology then?
It basically posits that biology is recursive structured motion. It's all these repeating, adapting patterns. Life itself, in this view, is rhythm-seeking tension resolution.
Our body's constantly adjusting, healing, finding balance.
Exactly. Constantly syncing and resyncing.
And then he pours all this understanding of motion into his arc.
Yes. He doesn't just freeze a moment in time in his paintings. He somehow captures unresolved motion.
Unresolved motion, meaning?
Meaning it feels like something is still about to happen or just finished happening. It's not static.
Like the Mona Lisa's smile.
That's the classic example. It's not fixed, is it? People describe it as a loop in tension mid-sync. You can't quite resolve it. It feels like it's changing as you look at it.
Caught between expressions.
Exactly. Or think about The Last Supper. That's not just a group photo. It's depicted as turbulence between 13 nested social loops.
13 loops. The apostles and Jesus.
Right. Their individual reactions, their interactions. It creates this incredible dynamic energy, almost chaos within the composition.
He had that quote, "A painting is a poem that is seen rather than felt."
He did. But maybe through this motion theory lens, we can see a deeper layer, like a painting is a motion loop held just before it resolves.
Capturing that moment of tension, of potential change.
And maybe that's why his art hits us so hard. Motion theory would suggest that art that resonates is unresolved sync tension.
Meaning we feel it because it presents a pattern that isn't quite finished.
Exactly. And our own minds, our own internal loops, try to resolve it. We feel that pull, that tension. His paintings move us because, in a way, they're still moving even though they're still.
Okay, so let's try and wrap this up. Looking at everything, water, air, machines, bodies, art. What's Leonardo's real legacy here? Specifically through this motion theory lens. He didn't write the physics papers. He didn't build a working engine.
He didn't need to. He did something maybe more fundamental. He watched reality with the eyes of a loop.
He saw motion everywhere.
Everywhere. Water, air, muscles, machines, even in minds and faces, in those subtle expressions.
And across all of it, he was asking that same basic question.
What is this motion trying to resolve?
Yeah.
What pattern is it trying to complete? What balance is it seeking?
The motion theory today just builds on that, gives it the math.
In a sense, yeah. It provides the framework, the analytical clarity for what Leonardo just saw intuitively. That motion is structured, it follows patterns. That rhythm is fundamental, it's reality. And that everything is constantly trying to sync up to find harmony.
He didn't just watch motion.
He became part of its unfolding, like a conduit for it.
So the final verdict, Leonardo da Vinci, more than a genius. He was like a pre-sync loop in human form.
I like that. A living example of these ideas. He saw the world as this incredible dance of motion, always resolving tension.
The sketches weren't just drawings, they were motion maps.
Right. And his paintings, frozen resonance.
And the machines he dreamed up.
Sync experiments, trying to capture that rhythmic logic in hardware.
So motion theory doesn't just honor Leonardo.
You could say it completes him. It gives language to his intuition.
Which leaves us with a final thought for you to chew on. Leonardo watched motion think.
And now maybe motion is watching back, revealing itself through the very ideas he helped spark. Welcome to the loop, Leonardo. It was always motion.